Hi, fifth grade. Thanks for joining me again. We're working today on lesson 88 of math. We're on page 458. You need your book, you need something to write with, and it would be helpful if you had looked over the lesson explanation on Jupiter. So let's get started. Today we're talking about transformations. Transformations are when you move one figure across a plane in order to lay it over another figure that is congruent. If you recall, congruent figures like triangles, rectangles, parallelograms, are congruent when they are the same shape and the same size. Especially for triangles, that means the same type of triangle, not just that they're both triangles. Congruent figures can fit one over the other, and one will cover the other completely. Like you can stack them like that. Okay? So we recall that figures are similar when they're the same shape but not the same size. So you can't stack similar shapes. You'll be able to see one or the other. So there are three types of transformations. The first type is translation. Translation means to slide a figure in one direction without turning the figure. So it just means if you have two triangles that are pointing in the same direction, but they're far away from each other on the plane, translation just means you slide one of them over next to the other. Translation is just sliding your plane figure. Reflection, reflecting a figure as in a mirror or flipping a figure over a certain line. So if you have two triangles and they're already slid together, I'm using my hands like they're triangles, which they're totally not, but that's okay. When we reflect, we just flip one over the other. Okay? That's what reflecting means. Okay? So my fingers here are the line, and then I just reflect one back to the other. Right? Our last transformation is rotation. Rotation is turning a figure around a certain point. So that means when you take one of your figures and you turn it in a circle, all right, but you keep the turn from one of the points on the figure. So rotations can be described by their degree and direction. The directions are clockwise and counterclockwise. Clockwise is in the direction that the clock hands turn, so to the right. Counterclockwise is against the way the clock hands turn, to the left. The degrees means 90 degrees, 180 degrees. 360 degrees is all the way. What's 3/4 of the way? Oh, 270 degrees. There we go. I remember how to multiply by 9. So when we turn something 90 degrees, we've turned it 1/4 of the way around. When we've turned it 180 degrees, we've turned it halfway around. We've made it upside down. When we turn it 3/4 of the way, we've made it the other side. And then 360, it would get back to the place that it started. Okay, so those are our three types of transformations. We use these to move plane figures across the plane. Let's look at our practice. So our practice A asks us to sketch an uppercase R after a reflection on its vertical segment. So here I have my R, okay? Let's see if I can do this with my pen. The vertical segment is the line here, like that, okay? So if I reflect it on my vertical segment, let's see if I can draw this. I'm going to do that. I'm going to make it look like I've held a mirror up to it and there it is flipped onto the other side, like a pancake. I flipped it over. Okay. B asked me to sketch an uppercase R after a 180-degree clockwise rotation. Sorry, counterclockwise rotation. So there's my R for B. So if I am turning it counterclockwise, I'm turning it to the left, and 180 degrees means that it's going to end up underneath my current R. So let's see if I can do this. They're not quite the same size. That's what your R would look like flipped 180 degrees counterclockwise. Okay. Question C, for questions C through F, we need to name the transformations that could be used to position triangle A onto triangle B. So if you look at C, we need reflection. We need to flip triangle B over on top of triangle A along the line that is joining them. For D, we need rotation. We need to turn triangle B 90 degrees clockwise so that it stands up and lays over triangle A. For E, we need translation. We just need to slide triangle B along the plane over triangle A. We don't need to move the position that it's in. We just need to move where it is. And then for F, there are different ways that you could lay triangle B over triangle A. So you could use reflection and translation. So you could use rotation and reflection, or you could use rotation, reflection, and translation. So I think it would be really great. You can make triangles like this if you get a piece of, if you get an index card and then a diagonal line across it and cut it, it will make two triangles that look basically like these ones. Use those triangles, position them on your paper the way that F looks, and try and see all of the different ways that you can move triangle A onto triangle B, and see if you can figure out all three ways to do that. I think that'd be a great activity. So I hope this has been helpful for transformations, and I will see you back here for more math later on. Have a great day, everybody.